Guys, when they ask you total distance traveled, okay, what you're going to have to do is put in a candidates test, okay? Always, always, okay? You put in a candidates test. This is T and this is XT, okay? In your candidates test, you're going to have your endpoints, okay? If this is traveling, this is your T endpoints. So if this is traveling for 3 seconds, do you see that you'll go from 0 to 3, right? Those are your endpoints for time. Okay, now the tricky part is what do you put in the middle? And the number one wrong answer is students just go 0, 1, 2, 3. It's a number one wrong answer, okay? Whenever you do a candidates test, you never get to just guess what goes in here. It's always endpoints and what else? Do you remember? Critical points, okay? And how do you find your critical points? Well, if this is F, you would say F prime equals 0, okay? So if this is X, what are you going to say? X prime equals 0. Okay, so where's your X prime equal to 0? Well, here's your X prime up here. Set this equal to 0. Okay, set this equal to 0, okay, and solve for T. I'm going to pull out a 2. If I pull out a 2, I'll get 3T squared minus 19T plus 6 is equal to 0. Now factor this right side. So that's 3T minus 1, T minus 6 is equal to 0. So you get positive 6, negative 19, okay? And then you say, well, now I've got something times something times something equals 0. What does that mean about one of these somethings? One of them must be 0, right? Okay, well, that means either 2 is equal to 0. Oh, that's silly. 2 is not equal to 0. Okay, 3t minus 1 is equal to 0. Okay, that would mean t is equal to 1/3. Or t minus 6 is equal to 0. Okay, so these are my critical points. I go take them and I put it into this chart. And you have to put them in order. So the 1/3 goes there. Where does 6 go? There. And what do I do with this 6? I delete, I disregard it, right? Because I only want to know between times 0 and 3, okay? Are you writing this down, Paula? Between times 0 and 3. Oh, you did, okay. Then what are you going to, the distance you're going to travel. Okay, so then I'm going to fill out the rest of this chart, okay? And the easiest way to fill out this chart, guys, is actually go into your calculator. And students are asking me, okay, well, what do I put in my calculator? What formula do you put in your calculator? Well, what's right there on your right side? It's your X, right? You want to fill out this table for X. So your Y equals needs to be for X, okay? So put in your X here. That'll be 2X raised to the 3rd power, okay? Minus 19T squared, so minus 19X squared, plus 12X minus 7. And I know my paper has T's, and I know my calculator has X's, okay? But it'll still work. They're just variables. To my calculator, it's just some variable. It'll still solve for X. If it solved for T, it'd be an X, okay? And then what you do is you hit second table set. Change your auto to ask on the independent. And I think if you already did it before and you didn't change it, it should already be there, okay? Hit enter, then hit second table, okay? I'm going to delete everything in this table. You actually don't have to delete it. You can actually just write over it, okay? But I'm going to copy these values into this table. So 0, comma, 1/3, comma, oh, not comma, enter, 3, enter, okay? And I put those values right into my paper. So I've got 0 is negative 7. At 1/3, X is negative 5.037. And then at 3, X is negative 88, okay? You put these numbers in. And actually, you want to go at least, you want to go accurate at least 3 decimal places. So I'm going to go further here. So in order to figure out what that negative 5.037 is, go put your cursor on it. When you put your cursor on it, you can see the whole number right there. Okay, so your whole number is 037037. It keeps repeating. All right. What you want to do now is get the difference between this. Okay, because what are you really doing? You're standing at negative 7. Then you're standing at negative 5. What's the distance between negative 7 and negative 5? Do you see that? So you take the difference between them, okay? So the difference between negative 7 and negative 5 is, let me go to second quit. Second quit clears your screen, goes back to your home mode, okay? It's going to be negative 7 minus negative 5, if that makes any sense. You're really just finding the distance between those 2 points. So it's going to be negative 7 minus negative, which would be plus 5.037. 037, okay? and that gives me negative 1.96. I'm going to go a little bit more than 3 decimal places, so I can be at least 3 decimal places accurate. Okay, if I sum that up, that's what this is. But guys, I only want the absolute value. I only want the distance between them. So I'm going to put like absolute value bar signs. Okay, all right, and then between negative 5 and negative 88, what's the distance between them? Okay, what are we really asking? I'm saying I'm standing at negative 5. Then I move to negative 88, right? What's the distance between them? So you're going to subtract those two numbers, okay? And so that's going to be negative 5.037037 minus negative 88, which is plus 88. 88, okay? So I get 82.962963. I just want the absolute value of that. It's already positive, okay? Then I add these distances together. So I'm going to put plus 1.962963, enter, and that's my total distance. You want to go at least 3 decimal places. So total distance is equal to 84.925. You can truncate, which means just drop everything else after the 3rd decimal place, or you can round correctly, okay? Either one, but you got to round correctly if you do round. And that is my total distance. Nice, right? The next question in K asks you for displacement. And the formula for displacement, okay, is your final position minus your initial position, okay? That's the formula. Just memorize the formula. It's your final position minus your initial position, all right? Well, let's see what they want the displacement of. From 0 to 3 seconds. So it's your position when you're at 3 minus your position when you're at 0. Well, what's my position when I'm at 3? Do you guys know what that is? What is my x when I'm at 3? It's right here in this chart. What is it? What is my x? Negative 88. What's my x when I'm at 0? Negative 7. Okay, so all you have to do is be careful of the negatives. That's all. This is negative 88. You subtract negative 7. So that's really negative 88 plus, right? Plus 7. Okay, so then you get negative 81, and that is your displacement. And displacement can be negative, okay? So some students will do this, and then they'll just change the sign, and then now you have it wrong, okay? Displacement can be negative. So if it's whatever it is, that's the answer, okay? Position at time t. I want you to understand that that's really xt, right? Position. The position is also st, okay? Velocity. Velocity is the derivative of position, okay? Velocity has its own letter, right? It's vt. But it also can be the derivative of x prime t, okay? And this is kind of like your family, right? You are your own person, but you're also the son of xt and st, okay? And then acceleration is its own person too, so at, okay? But it also is the derivative of velocity, okay? But that means it's the derivative of x prime, which means it's the second derivative of t, or the second derivative of s, okay? So all of those things mean acceleration. Now, if you're moving to the right, or if you're moving up, okay, what that means is you're on a number line and you're moving to the right. You agree? So what number is increasing? Is it my x that's going up, or is it my v that's going up when I come this way? It's not my v. Do you see? Because it's not my velocity, right? It's my x, because I'm going x1, x2, x3, okay? So this is going to be your x is increasing, okay? Or if you think about it, it's your x is going up like that. Your picture would look like that, okay? Moving to the left or moving down, okay, well, that's just your x's are going down, right? -1, -2, -3, -4, okay? So that means x is decreasing, okay? Or you could say x is going down. That would be what your picture looks like, okay? But remember, moving to the right is also, if x is increasing, then x prime is positive, right? If x prime is positive, x is increasing. You guys know that, right? If f prime is negative, okay, then x is decreasing. You guys already know that, okay? Well, if that's true, what's another name for x prime? Velocity, okay? So this thing is the exact same thing as velocity being positive or velocity being negative. All these things are the same things. It gets confusing because they all have different names, okay? But they're the same things, v and x prime. All right, what if I want furthest to the right. If I want furthest to the right, if you think about, we draw these pictures like X, you know, X is moving up, then X is moving down, then X is moving up. Well, the furthest to the right would be the biggest number for X. Do you agree with that? It's the biggest number for X. So this would be maximizing your X, okay? The biggest number. And so to do that, if you look at, if X were doing something like this, don't you agree the biggest X would either be here or here, right? You're looking at the highest X, the biggest X value you can get, okay? And so if I were doing this problem, it said furthest right or up, I would, you know, I would actually get this little increasing, decreasing thing, and just FYI, you know, that would be from a V number line prime, V prime thing, positive, positive, negative, negative, positive, positive. You've done this before, right? Because that's what furthest to the right means. If I have my X, okay, so X is the position, you agree? So if I'm at, let's say I'm at X 1, 2, 3, 4, turn around, 1, 3, 2, I can't count backwards, 0, negative 1, negative 2, turn around, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, turn around, 6, 5, 4. When was my biggest furthest to the right? Isn't that my biggest X? Does that make sense? The highest X. Because when you graph your position, it's the highest. Because if you do position versus time, you actually, even though I'm walking horizontally, when you graph this, I'm at 1, then I'm at 2, then I'm at 3, then I'm at 4, then I'm coming down. Does that make sense? So when you graph it, it actually is, does that make sense? It actually is the highest X value when you graph it, okay? So that's walking, you know, this actually means walking right. This actually means walking left, okay? And we say right, left, it could also be up and down. It just depends if you're on a horizontal number line or a vertical number line, okay? Furthest left or furthest down, okay? So if I'm a number line, that's my smallest X, okay? So if this is maximizing the X, this is minimizing the X, okay? And so if I minimize X, if, you know, if I had some sort of graph like this, okay, my minimum would actually happen either here or here, right? It's one of those that's going to be the lowest points. I don't know which, and to figure out which one it is, I'm probably going to have to do, like I'll have to test that point and just pick the lowest one. It'll probably be like some sort of candidates test, okay? At rest means what is equal to 0? Velocity, okay? Make sure you know that at rest means V equals 0, but when I say the minimum V, that doesn't mean V equals 0, and I'll draw you a picture in a second. Here, I'll draw you a picture right now. Yesterday we had this picture, okay? Our velocity was like this, okay? And I think, I don't remember the numbers here, but I think it was like 1/3, and it might have been 6, okay? And so guys, if I asked you, when are you at rest? When are you at rest? It would be here, okay, remember this is a V, so this picture is a V picture. It'd be here and here, right? That's when my V is equal to 0. But if I ask you, what's the minimum V? What a lot of students is, they tell me when you're at rest. Actually, there's a smaller V than that. Does that make sense? The minimum V means you can go negative, okay? So the minimum V actually happens right here, okay? The minimum V happens when the derivative of V, guess what, is equal to 0, right? That's the minimum V on this picture, okay? But a lot of students, instead of giving me minimum V, they're giving me minimum speed. Does that make sense? Minimum speed is when V is equal to 0, but that's not what minimum V is, because V has signs, right? So minimum V is just draw your V and go grab the lowest point that you can grab, and it can be negative. When does the object change direction? Well, look at this. If your picture looks like this, when do I change direction? Right? Is it every time I turn around, I change directions, right? So what is that really? It's when what changes? There's two possible answers, right? It could be when X changes from increasing to decreasing, or vice versa. Do you agree with that? That's when I'm turning around, okay? When X goes positive, and then I turn around when X is decreasing, not positive, sorry, not positive and negative. X is increasing, Okay, x is decreasing. Do you guys agree? Every time I turn around from increasing to decreasing, that's when I change direction. But remember, this is a number line down here. If this is x, then guess what my number line is? X prime. And the x prime, if you remember, is when x prime changes from what? Positive to negative. Okay, so it's when velocity, okay, changes signs. Okay, that's when you change direction. Okay, when velocity changes signs. Okay, and basically they're just all the relative maxes and relative mins on x. Okay, when is speed increasing? Okay, so we talked about this yesterday. Okay, speed is increasing if you have a graph, and this is my velocity graph. Okay, remember, speed is increasing. No, wait, speed is not increasing there. Speed is increasing. Take that out. Speed is increasing here, right? Or is it not? Decreasing. Speed is decreasing here, right? Because I'm going like 30 miles per hour, then 20 miles per hour, then 10 miles per hour. This is my v. Speed is decreasing. Okay, right here, is speed decreasing or increasing? It's actually increasing. It doesn't seem like it should, but look, if this is negative 10, what's this number down here? Negative 20. Well, what's the speed right here? 10. What's the speed right here? 20. Do you see my speed is increasing? Which is weird. Like, it's negative, but it's increasing. You can be negative and increasing. That's fine. Okay. And then over here, my speed is decreasing. Okay. And then up here, my speed is increasing. Okay. So speed is increasing, and we talked about this yesterday, I think. I don't know if we did. Did we talk about it yesterday? When velocity is getting closer, did we talk about this? To the x-axis. And you can call it the x-axis. It's technically the t-axis, okay? Because it's time here. What did you say? Did you say something? No. Oh, did I do it wrong? Oh, yes, yes, you're right. It's getting further away. Yes, sorry. Getting further away from the t-axis. Thank you. Okay. And then the opposite is true for speed is decreasing. So velocity is getting closer to the x-axis. Okay. So then another way to say this, though, okay, when speed is increasing and speed is decreasing is this. I'm going to write this down, and then I'll show you guys why. When speed is increasing, another time speed is increasing is when acceleration and velocity have the same signs. Speed is decreasing when acceleration and velocity have different signs. Okay, and I think I illustrated this yesterday, but I want to make sure you understand. It actually makes a lot of sense. Okay, if my velocity is negative, I'm walking to the left. If acceleration is negative, the wind is blowing to the left. If I'm walking to the left and the wind is blowing to the left, if my velocity is negative, my acceleration is negative, am I speeding up or slowing down? I'm walking this way, the wind's blowing this way. Am I speeding up or slowing down? I'm speeding up, right? So if acceleration and velocity are both negative, they're both going the same direction. Does that make sense? The particle is going the same direction. So therefore, as the wind, the particle and the wind are going the same direction. So you're going to speed up. But if I'm walking this way, my velocity is positive. Everybody good? Velocity is positive. And the wind is blowing this way. The wind is going negative. Am I speeding up or slowing down? Slowing down, okay? So when your signs are the same, you're speeding up. When your signs are different, you're slowing down. So what students do wrong is they just say, oh, when acceleration is negative, you're slowing down. When acceleration is positive, you're speeding up. Not true, because it depends on which way the particle is going, okay? And this jives actually with this. These two actually jive together. And so I don't know if we showed that yesterday, but they do jive together. Okay, the last two is displacement, okay, and total distance. Displacement, I think, is pretty easy. The only problem you'd have here is if you forgot the formula, okay? So it's just your final position minus your initial position, okay? And it can be negative, so make sure you know. If it's negative, you got to leave it negative. It can be negative, okay? Your total distance, I think, is the toughest one, okay? Your total distance, you actually have to remember. There's no way to write anything here. I just write a candidate's test. That's why I put it last, so you can actually draw this. I just make a candidate's test. Inside your candidate's test, you need to put your endpoints, okay? you need to put your critical points, okay, whatever they are. I don't remember what your critical points were, whatever they are, okay. And then you need to find your values, okay, so whatever your values are here, whatever the values are here, you'll put it into your function xt. Then do you remember you get the differences? You take the differences here, okay, make sure all these are positives, okay, so I'm going to put absolute value. Okay, get your differences, but you make them all positive because it's distances, and then you add them together, and that answer is your total distance. So here we go. There's two ways to, well, when is the particle moving to the right? Think about this. If I want the particle moving to the right, I want like to get the x's. Does that make sense? Like I want to get like these x's, okay? And if I get x going up, like this is when I'm moving to the right, right? When x is going up, okay? But when is x going up? What you do is actually, if you want x's, you always have to take one derivative. That's just kind of the key here. If they ask you something with x's, then you have to take the derivative of v. Like if they ask you for minimum velocity, you have to take the derivative of velocity. So you actually need x prime, okay, which is actually called v. And you get the critical points for your x prime, okay? You do plus, 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 minus, 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 and that'll give you your picture, right? Okay, so what I have here is x. I need x prime to get my number line here, okay? So what is x prime? Well, x prime is the derivative of this. Now, there's lots of ways to do it. We can FOIL this out. I mean, we could go, this is t squared minus 4t plus 4 times t minus 6, okay? Then FOIL that out. Do you want to do that? Or do you want to change rule? I don't really care. Do you want to FOIL that out? Okay, let's just FOIL this out. So this is, if you remember how to do this, you just take your t squared and you multiply by these two things, right? So that's going to be t cubed minus 6t squared. Then you're going to take your next one. Take your next one. Negative 4t, and you're going to multiply it, okay, by these two things. So now that's negative 4t squared plus 24t, okay? And then lastly, you just take your 4 and you multiply it by these two, the t and the minus 6. So I have plus 4t minus 24, okay? Combine all your like terms and then take the derivative. So what I have is t cubed minus 10t squared plus 28t minus 24. And that's still your x. So this is x equals, this is x equals. And let me get my derivative. My derivative will be x prime. X prime will be 3t squared minus 20t plus 28, right? Okay, that's x prime. And then you need an x prime number line, okay? Now, these critical points, okay, are when x prime is equal to 0. So I'm going to set this x prime equal to 0 and solve for t, and those are going to be my critical points in here. Now, to solve for t, let's see, can I take anything out? I don't think I can. I don't think I can. So let's just go ahead and do this. This will be 3t times t. And I do a box. You know what I'm saying? This is basically what I do. Some of you guys do boxes. So I'm saying 3, 1, and this is going to be 7, 4. And does that give me 20 in any way? 12 and 7 doesn't give me 20. 21 and 4 doesn't give me 20. Okay, instead of 7 and 4, maybe it's, what times what is 28? 2 and 14? Okay, 2 and 14. So that gives me 6 and 14. That does give me 28, right? That does give me 20. So 3 in one place, 14 in the other, and 2 in this place. See if this works.
That is not equal 20.
That is not equal 20? 6 and 4? 6 and 14? 6 and 14. Yeah, that does give me 20. I think that's right. I don't know if my signs are right, though.
Yeah.
Okay, yeah, I think that's good. All right. Okay, so that's what I have. Okay, so why did I factor? Because if you have something times something equals 0, what does that mean about one of these somethings? One of them must be 0. So either 3t minus 14 equals 0, or t minus 2 is equal to 0. Over here, that means t equals to 14 over 3. Over here, it means t equals 2. And these are the numbers where your velocity is equal to 0 or your x prime is equal to 0. Remember, this is x prime, but it's also called velocity. Okay, so I'm going to put these critical points in, 14/3 and 2. Oh, wait, I think that's in the wrong order. I think 2 is smaller. So 2 on this side and 14/3 on this side. Okay, this isn't going to apply here. Okay, I need to, every time you do your velocity number line, do your plus, 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 minus, minus, minus. Okay, how do you do it? Well, go stick, whoa, wrong thing. Go stick your velocity curve into your calculator. Okay, what is my velocity? Do you see my velocity? How do I get out of this? Okay.
So just stick that the derivative.
Yeah, this 3t squared minus 20t plus 8. So go ahead and stick that into your calculator. See what it looks like. Okay, so I'm going to put in 3 x squared minus 20x. What? I look what? Oh, I don't think I have to clear it. I should have. You're right. I don't think I have to clear it. I just hit delete like when I'm done, like 30 times. I should clear my calculator. Thank you. Okay. So 3x squared minus 20x plus 28. Thank you. Okay, I'm going to graph the velocity curve. Now, what does this velocity curve tell me? It tells me that these are my critical points. I already have these 2 points. But when you're above the x-axis, guess what? Your velocity is positive. When you're below the x-axis, your velocity is negative, right? This is my velocity curve, and this is positive. So if this is x prime, right? We said this is x prime. Then guess what x looks like? Increasing, decreasing, increasing. This is my x. This means I'm walking right, okay? Then I'm walking left, then I'm walking right. Okay, that's what it means. All right, so when is a particle moving to the right? The answer will be when t is equal from 0 to 2, and also 14/3 to infinity. You guys check me if I'm wrong, okay? Let me know. You guys good with that? And I could answer the question to the left too. If they ask me to justify that, I would say because x prime is positive. Or you could say because v is positive, same thing. Okay? Now, when is the particle at rest? Remember, we got to know these key words. What does at rest mean? V equals 0, okay? So that just means when v is equal to 0, exactly, we already figured that out, right? When v is equal to 0, when is the time? Well, look, it's these 2 times right here. This is my velocity curve. So that's going to be 2 and 14/3. Okay, next question. When do I change directions? When do I change directions? Yeah, right here, right? I'm going right, then I'm going left, then I'm going right. Okay, so the changing direction, if you understand it, it's your relative max and mins. Okay, it's your x's, your relative max and mins on x. Okay, so when do I change direction? I change direction at 2, at t equals 2, and at t equals 14/3. Okay, so you just take all these questions one at a time. You can do it, just take it one at a time. Next question. What is the furthest to the left of the origin that the particle moves? What is the furthest to the left? Okay, so think about this picture here, okay? When would furthest to the left happen on this picture? When would furthest to the left happen? Would it happen at one of these top points, or would it happen at one of these bottom points? Bottom, okay, so let me just circle it. It's gonna happen either here, or it's gonna happen here. Okay, so it's either gonna happen at 14/3, or it's gonna happen, guess what point this is? 0, because actually somewhere up here it says, here, start at t equals 0. Okay, so you agree, it's only going to happen at one of these points, right? And how do I know which point it will happen at? Well, it's going to be the one with the lowest x, okay? So here's my question. If I know t is either equal to 0 or 14/3, can I find my x? Yeah, you can find your x. So go put this in your calculator, and the one that has the biggest or smallest, the smallest x would be the lowest, right? Yeah, Paula?
How do
that it's one of these? Yeah, okay, so let me walk it for you, see if this makes sense. So this is time 0, I'm going to go right? So I'm going to go right, then I'm going to go left, right? Okay, so for sure that wasn't furthest to the left because I'm walking back this way. Does that make sense? So I'm walking right here to the left. So I'm going to walk to the left, and then I'm walking back right. So it had to be, it could have been that point. Does that make sense? So it's kind of like, it's really, if you make sense, it's a minimum. It's only at one of the minimums, okay? So furthest to the left actually means minimize your x, is what it means. So it's a candidates test, but you don't have to put every point in. You just put your candidates, the ones that you suspect, okay? And you can do that in your calculator with the x. Now, guys, if this is x, students are always like, okay, what do I put my calculator in? The x prime, the x prime. Guys, if this is an x, that's what you put in your calculator, the x, okay? And I think we already knew, oh, I don't know. If we,
-24 and 9.
Okay.
-9.41.
9 point. Okay, so then what's going to be your answer? The furthest to the left, right? At time, what is the furthest? Oh, the question is, what is the furthest to the left? So the answer is going to be -24. Okay, that's the point. That's the position you're on when you're furthest to the left. If they ask for time, you would say 0. Did we finish this problem? Nice. Okay.